Welcome to the webcast, Common Oil and Grease Audit Findings and Appropriate Responses by David Gallagher and Chad Shuey. We're going to start today by discussing some of the basics for this method. Then we're going to get to the part that's good and discuss the range of varying audit concerns that have come up in the past 20 years that Horizon Technology has been in this business. We're going to finish by speaking generally about some topics that should be brought into consideration when you take a look at the technique that you follow. Oil and grease goes by a few different names. For example, in Europe it's called Hexane Extractable Material. It also may be called fats, oils, and greases. So to be sure that we're all speaking about the same thing, what we're talking about today are those analytes which are extracted out of an aqueous matrix by N-Hexane. As a subset, if we treat N-Hexane extract using silica gel, we get only the non-polar materials as specified by the method. The oil and grease method is applicable to a wide range of matrices, including wastewater, industrial waste, and saline water. It can be used for the control of pollution, but is also used for monitoring waste treatment plant operations. Historically, the extraction procedure has used a separatory funnel to serially shake an aqueous sample using N-hexane. More recently, however, many users have converted to performing solid phase extraction, which filters the sample through a solid phase disc and then elutes from that disc using N-hexane. This is a great place to start our audit topic discussion. While the US EPA Method 1664 Rev B specifically says that you can use SPE, we've gotten a lot of questions regarding demonstrating a proof of equivalency. In Rev A, most users were required to prove that the SPE procedure worked for their particular waste stream. So, do you also have to do this in Rev B? Let's start by just answering the question of what is needed to prove equivalency. You have to run an initial precision and recovery sample and method detection limit, which is no big deal. But if you're going to use your data for compliance work, you also need to run a matrix comparison for each waste stream. This last step could turn out to be really burdensome, right? The good news is that the method specifically says that any of the modifications given in section 1.7.1.1 are exempt from having to run an equivalency study on waste streams. Since SPE is written in there, we're good. Now, that's not to say that you don't have to run an IPR and MDL. Those are still required. So I'm allowed to run solid phase extraction. That's great, but the SPE vendor lists methanol as one of the solvents. Can I do that? Well, the reason that most SPE manufacturers use a water-soluble solvent in the extraction process is to remove residual water from within the disc or cartridge. Think about it. We process an aqueous sample which has all sorts of stuff in it, including leaves and dirt and God knows what else. Then we squirt hexane on top of it and just expect the hexane to go through the water to get to the target oil and grease. This is a recipe for low recoveries. As an example, Horizon Technology took and extracted a set of samples from our local wastewater treatment plant, one set with methanol and one without. What we found is that there was a 42% loss in analyte recoveries when methanol wasn't used. So to come back around to the question of compliance with co-solvents, the answer is that you're only out of compliance if you're using the co-solvent as an extraction solvent, meaning you let the co-solvent go into the final extract. If you use the co-solvent as a wash step and simply send it to waste, that's fine. The caveat, though, is that the individual lab has to prove that there is no co-solvent left on the disc to interfere with the results. So how do we do that? In the method, there is a procedure given where we take a dry SPE disc and record the weight. Then we process a blank through the disc and dispense the polar solvent. We then air dry the disc, collecting weights at set time intervals until the weight is 101% or closer of the original weight of the disc. While the procedure makes sense, the problem is that there are a lot of interferences which are introduced to the disc in that time. In testing that was performed, this technique ended up taking more than an hour for the disc weight to drop to 101% of the original weight. Instead, what we suggest is that the user process a blank but takes the tare weight just prior to the polar solvent being dispensed. Once the polar solvent is introduced, dry the disc using the same technique as before, measuring the weights at set intervals until the weight is 101% of the original weight. This technique takes only 2 to 3 minutes. You might hear some vendors say that they don't use methanol at all. I challenge those people to run a wastewater sample side by side with LLE and to publish the results. If that disc has a lot of stuff on it, then recoveries will certainly be poor. Once we've established the extraction technique, the next step is to talk about spiking precision and recovery standards. Now, the method calls for 20 milligrams each of hexadecane and stearic acid to be added to the sample. But for those people who make their own standard or who purchase a vial containing multiple aliquots, it's convenient if they could spike less so that the cost per sample decreases. According to the method, this is fine. I've been told in the past that the smaller diameter discs are for clean samples, while the larger diameter discs are for dirty ones or ones with more particulate. Can I use the 47 millimeter discs for my QC and the 100 millimeter discs for my samples? Simply put, no. If you're going to use a particular brand and size disc, you should stick to it throughout the batch. You should also be aware that each brand and size disc that you use must have its own control charts. But what about pre-filters? Do we treat them the same as discs? The goal here is to filter all types of aqueous samples through a disc that is about the same thickness as a penny. If we use only an SPE disc, odds are good that we'll have some sort of trouble. Many vendors have techniques for running dirtier or samples with more particulate, mostly involving the use of pre-filters. The method allows for pre-filters to be handled on a sample-by-sample basis, just like the traditional emulsion breaking techniques. Let's say you've got to use the centrifuge to break an emulsion, but you don't use it for the entire batch, do you? No. Pre-filters are exactly the same. But what happens when pre-filters aren't enough? How much sediment can I run using SPE? We get this question all the time. Usually, this comes from someone who has tried cartridge SPE in the past and remembers all the problems associated with that. Processing times depend on a lot of things, but mostly it depends on the geometry of the system. This means that the volume of the disc holder, as well as the shape and type of particulate being loaded into the holder, all matter. So what do you do if you have too much sediment in your sample? Simple. Reduce the sample volume that is being run. The method, in its latest revision, allows for smaller samples to be collected for complex matrices. The caveat here is that whatever you collect, you have to run. But what do you do if you received a sample that you think won't flow? Well, you can simply split it into 2 aliquots, extract them both, and recombine them at the end of the process to get one reportable number. Since you're running the entire sample and rinsing the original container and cap, there's no breach of the method. You said I have to rinse the cap? Why is that important? It's important because a lot of oil and grease floats on the water, and you can be missing a significant amount of the extractables by not rinsing it down. Let me give you an example. A few years ago, there was a company selling PT samples which had vacuum pump oil rather than hexadecane and stearic acid mix. Horizon Technology got more than a few calls where the underlying problem was that the user was not rinsing the bottle cap. Secondly, it's really important to know how to rinse the cap. Occasionally, we get calls where the users are following the PT sample instructions and rinsing the cap with hexane only to put it back in the bottle and try to run it by SPE. The problem is that the hexane extracts some of the targets, and then when we filter the sample, both the hexane and water go directly to waste. Cap rinses are extremely important and are called out in the method. For LLE, you can rinse the cap and put it in the extraction vessel. For SPE, you don't put the rinse in the bottle, but in the disc holder during the rinse step, so that the hexane is collected rather than discarded. With the extraction done, now it's time to dry the sample extract. There's a lot of variation in how this technique is done, from sodium sulfate to PTFE membranes. Some people even skip the actual drying step by using a separatory funnel to separate any residual water from the extract. Recently, a document released in Arizona featured a quote from the EPA stating that all the techniques listed are acceptable except careful pipetting or draining to separate the water away. So if all extracts must be dried, then some labs will just incorporate sodium sulfate into the process because it's familiar, cheap, and easy, right? Well, when your analytical technique involves using a balance to weigh the final product, there's an awful lot that can go wrong in that process. You may be using pre-packed cartridges that don't have enough sodium sulfate in them, and you may have water pass through. You may not seat your filter paper correctly, and the fines will get through. Or you may not rinse it well enough at the end of the process, so you might lose recovery. All of these things point towards sodium sulfate being easy to have a problem with. The truly easy way to dry your extracts is to use a membrane to physically separate rather than to chemically separate the water from the extract. Okay, now we've got to distill off the solvent. But what temperature do I use? In the past, Horizon Technology had a lot of users complain that their auditors were telling them they had to use 70 degrees C. By the time it looks dry, it's too late. What do I mean? The temperature setting controls the speed of evaporation. To get the process to go faster, many users turn up the temperature. But now what happens when the analyst looks away for just a second? All the hexane has evaporated, and now the light ends of the target analytes are being lost. Conversely, if we turn the temperature down too far, the process takes too long, and we're simply wasting time which could be better spent running more extracts. So it's a fine line to walk between faster turnarounds and the possibility of recovery losses. The important thing to note is that the temperature is up to you. As long as you pass all the QC, it's fine. Well, I've pulled my vessel from the heat source and have taken a weight. Am I done? Not really. When you remove the vessel from the heat source, there's still some residual heat retained in the vessel which needs to dissipate. Glassware needs more time to cool than aluminum pans. As the heat dissipates, the weight of the vessel with the extract will change slightly. If we remove it from the heat source too late, we risk evaporating off the lighter compounds. This is why we pull the vessel from the heat source prior to the full solvent evaporation. This should also make the need for the process of repetitive weighing more obvious to those in the lab, since even when the pan appears dry, there may still be some solvent which is evaporating. So do you have to take repetitive weights? Absolutely! By sampling multiple times, you are able to tell with certainty that you have achieved the true final value. As for how long you should wait between measurements, the method says 30 minutes, but we truly believe that if you incorporate a drying step and lower temperatures into the process, you should be able to reduce the time between measurements. There are a lot of different things to consider when setting up to run EPA Method 1664. And it's important to pick the extraction, drying, and concentration technique that allows your facility the most flexibility for the types of samples that you get in. If you think most of your samples will form emulsions, maybe you should consider SPE. If you think that most of your staff are better equipped to use separatory funnels, go with LLE. At the end of the day, what's most important is how the technology works for you.